Okay, so today we are going over section 8.3. We essentially are going backwards from what we talked about in the previous section, where now we are given a shape and we have to kind of prove that we have a parallelogram. So we're going to use those different properties of parallelograms that we talked about in order to show that either yes, this is a parallelogram, or no, it is not a parallelogram. So that is kind of our goal for today. The first question up here, it says, how can we determine whether a quadrilateral is a parallelogram? There are 5 different rules. So there's actually one additional rule compared to the 4 properties that we talked about the other day. So the first way is to use the definition of a parallelogram. You'll kind of have to bear with me here as I'm learning how to use this program as well. If a quadrilateral has both pairs of opposite sides that are parallel, then it is a parallelogram. So if a quadrilateral has both pairs of opposite sides that are parallel, then I know I have a parallelogram. So what that looks like then on my picture down below here, I'm going to use a different color. Again, we use those little triangles to depict that we have our parallel sides. Okay, so I've got one set and I have 2 sets here of parallel lines. So if I have that, then I know that I have a parallelogram. All right, the second way involves the sides. So if we have a quadrilateral, both pairs of opposite sides are going to be congruent, and then I know I have a parallelogram. So if it has both pairs of my opposite sides that are congruent, meaning that they're the same length. So in my figure down below here, if I know that this side length is congruent to this side length, and these 2 side lengths over here, if I know that those are congruent, I need both pairs, then I know that I do have a parallelogram. Okay. Then our third one involves the angles. So the other day we talked about the opposite angles, those 2 sets being congruent. So if we have that, then we know that we have a parallelogram. So if a quadrilateral has both pairs of opposite angles that are congruent, then I know I have a parallelogram. So on my picture here, again, our opposite angles have to be congruent, and I need both of them. Then if I have that, then I know that I do have a parallelogram. All right, our fourth one, this was the 4th property that we talked about, with our diagonals. So those diagonals we noticed when we drew those 2 lines, or when those lines were drawn in that go across like this. Sorry, it's a little squiggly. They should be straight. But those 2 diagonals there, we measured and we found that this and this, those 2 were congruent to each other, and these 2 side lengths here were congruent to each other. In other words, those 2 diagonals bisect each other, or like this point where they cross was right in the middle of both of those. So if a quadrilateral has diagonals that bisect each other, then I know I have a parallelogram. Okay, now if it bisects only one side, so for instance, if only like this side here and this side here were congruent, but these 2 diagonals were not congruent, then it is not a parallelogram, because both sets need to be bisected. Okay, our very last one down here, our very last property, you have to know something about one of the pair of sides. So if a quadrilateral has one pair of sides that is both parallel and congruent, then it's a parallelogram. So what does that look like? Well, let's say I have, here is my, oh my goodness, that looks awful. Let's try this again. Okay, so if I have my parallel sides, I know that these two sides here are parallel. And I also know that those are congruent. That same side that is parallel, if those are also congruent, that means I have a parallelogram. I don't need to know anything about my other sides. So if a quadrilateral has one pair of sides, that is both parallel and congruent, then I know I have a parallelogram. So that's kind of a new one that we haven't really talked about before. Now, the cool thing with all of these different properties here is that if one of these happen to be true, so for instance, if I know that this right up here is a true thing, if I can see that one of my sides is parallel and it's congruent, that means all of these other properties up here are also true. So once I know something about one of them, then everything else is automatically true as well, because it's a parallelogram, so it has all of those other properties. Okay, so we're going to go ahead and flip our page over here, and we're going to go through a couple of examples looking at these different properties. So last semester, some of you may remember in example 1 here, it says, suppose you build a quadrilateral out of 4 clickies. So those clicky things there were a bunch of different colors. There was like purple, red, blue, orange, and you tried to make different triangles out of these different clickies. And the clickies had different lengths. So let's say that I have 4 of these, and I have 2 red ones, and we'll say 2 blue ones. Now, it does say here that 2 of each of 2 colors, so we said red and blue, alternating between one color and the other. Is it a parallelogram? So if I were to essentially click these together, so I've got a red, a blue, another red clicky, and another blue clicky, and I click all of them together, does this make a parallelogram? So the answer here would be yes. These different clickies, the same color means it has the same length. So this side is congruent to this side, and this side here would be congruent to this side. So therefore, because I have 2 sets of opposite congruent sides, therefore I do have a parallelogram. So yes. Okay. All right, we're going to look down here at example 2. Is the shape a parallelogram? If so, how do you know? So you need to go back and look at those properties. Here I can see that this side length here is 26, and this side length here is 26, which means those are congruent, which is good. Now I just need to check my last side there, and I can see that these lines here show that those are congruent. So yes, this is a parallelogram. And it says, how do you know? Well, I've got my opposite sides that are congruent. Okay. All right, let's move on to example 3. Here, those triangles right there show me that those are parallel. So I have one set of parallel lines, and here those 2 depict that those 2 are parallel. So I've got 2 sets of parallel lines. So yes, this is a parallelogram because I've got my 2 sets of parallel sides. All right, let's move on to example 4 here. Now, this x, 3x, x, 3x, those are my angles. It doesn't actually tell me what my angle measure is. However, whatever x is, like let's say x was I don't know, 25 degrees or something like that. Okay, then I could say, well, I know that this right here is 25 and this right here is 25. So that's one set of opposite angles that are congruent. And then if I know, again, x is 25, 25 times 3 is 75. So I would know that this blue angle here is congruent to this blue angle here. So I have two different sets of opposite congruent angles. So yes, this is a parallelogram. Okay, and I've got two sets of my congruent angles. Okay, so basically we're just going backwards from yesterday. Yesterday they told us we had a parallelogram and we had to use the properties to find x. Now we're going backwards. Okay. Example 5, it says, what value must x have if the shape is a parallelogram? So in order for it to be a parallelogram, I need to figure out what parts would be congruent. Now, these are my diagonals here. So if I look at my 2x plus 5, that right there should be congruent to this side length right here. My diagonal right here is bisected or cut in half by this diagonal right here. So if they're congruent, that means I need to set them equal to each other and solve for x. So I've got 2x plus 5 is equal to 4x minus 3. So I'm going to go ahead and subtract my 2x over to the side over here. So I should have 4 minus 2 is 2x is equal to, I'm going to add 3 over to the other side. So I've got 8 here. Divide both sides by 2, so x should equal 4. If x is equal to 4, then I have a parallelogram. Okay, example 6. Now we're dealing with our angles inside, and there's actually a couple of different options here that you could do. So I can see that this angle here and this angle here, those should be congruent to each other if I have a parallelogram. Those are my opposite angles. So I could set those two angles equal to each other. Another option that I have is that I know that I have two consecutive interior angles. I've got two different sets of them actually. So I've got this angle here, 9x plus 9, plus this angle here, 8x plus 1. That should equal 180 degrees. Or I can look at this angle, my 8x plus 1, plus my 12x minus 21. That also should equal 180 degrees. So I'm going to go ahead and, I don't know, I'll set this angle here equal to this angle over here. So I've got 9x plus 9 should equal 12x minus 21. If you want to try the other one to see if x equals the same thing, you can go ahead and do that. So we're solving, subtract 9x on both sides. So I have 9 is equal to 3x minus 21, so add 21. So I've got 30 is equal to 3x, divide both sides by 3, so x should equal 10. Okay. So again, you have a couple different options when you're solving that one. Now, example 7, this one here, it says measure a 2-inch distance on each line. So I'm just going to approximate this because I don't actually have a ruler with me. But I'm going to say that this point here to this point here, that is 2 inches. Okay, then it said to do it on both ends. So I'm going to come down here then, and I'm going to say this to this is 2 inches. Again, I'm just approximating. Now I'm going to connect my 2 points that I have in a nice straight line. And I need to determine, is this shape here that I drew, is that a parallelogram, yes or no? Now, if I could draw a straight line, it may look a little bit more like a parallelogram. However, I know that this side length here and this side length here they're both parallel. And I also knew that this was 2 inches and this is 2 inches. So that means that those two sides are congruent. So I have one set, whoops, wrong thing. I have one set of sides that are both parallel and congruent to each other. So because of that, I do have a parallelogram. Yes, because my one side is both congruent and parallel. Okay. So basically we get another day to kind of look at some of these properties of parallelograms and determine different missing values for our x. Your homework is listed at the bottom of the page here, page 526 and 527, 4 through 6, 8 through 10, 15 through 17, and 19 through 21.